Hello students, in this video let us see what is unit step function and its properties and how to solve its Laplace transform of unit step function using the property. Okay, let's understand the definition first. So unit step function, or it is also called Heaviside function. The unit step function or Heaviside function is denoted by u of t minus a or h of t minus a and is defined by 0 for the range t less than or equal to a, 1 for the range t greater than a. So let me take the graph t value and u of t minus a vertically. So 0 and t is a, I'll mark u of t minus a is 1. So from the graph we note that the value of u of t minus a suddenly jumps from the value 0 to the value 1 to the value 0 to 1 to the value 1 as t tends to a and retains the value 1 for all t greater than a. This is why the unit step function u of t minus a is called unit step. We required Laplace transform of unit step function is what? The formula Laplace transform of unit step function is defined by e power minus as divided by s. So you can prove this using the definition of Laplace transform of f of t is integral 0 to infinity e power minus st f of t dt. By substituting, see here, we have f of t, Laplace transform of u of t minus a. We have u of t minus a 0 for 0 to a. 0 to a, the integral becomes 0 because the value of unit step function is 0. Then a to infinity, t greater than a to infinity, the value of u of t minus a is 1. So the function value is 1. So then on integration of e power minus st divided by a minus s, so applying the limits, we get the result e power minus as by s. Now let's understand one of the important property to solve the problems in unit step function. The property called Heaviside shifting property. This property states that Laplace transform of f of t equal to f of s, that we know. Then Laplace transform of f of t minus a, u of t minus a product is equal to e power minus as into f of s. So we know that f of s nothing but Laplace transform of f of t. The same property can be rewritten as Laplace transform of f of t. Instead of writing f of t minus a, I'll write f of t. U of t minus a is e power minus as into Laplace transform of f of t plus a. Just I changed this t minus a to t and this t become t plus a. So when you are solving the problem, let us use the property in this format. For example, if we have the function in the form of, so suppose if you want to find Laplace transform of e power 5t into unit step function u of t minus 6. So here we have to find take the a value from unit step function, a is 6 and this is f of t. So therefore, according to the property, you can write this as e power minus as, nothing but e power minus 6s, Laplace transform of f of t plus 6. What is f of t in our problem? It is e power 5t. So therefore, this can be written as e power minus 6s, Laplace transform of e power 5 into t plus 6. So then, you can take this e power minus 6s and from this you can take e power 30 out, then it will become plus 30 the power. Then we are going to find Laplace transform of e power 5t. So finally the result is e power minus 6s plus 30 and Laplace transform of e power 5t is s minus 5. So this is how you can use the Heaviside shifting property. So same way, let me take one other problem to understand the property. So the next example I'll take Laplace transform of sin t into u of t minus phi. T minus pi. So here what is f of t? F of t is sin t and u of t minus pi we have. So a is pi now. A is pi. Therefore, according to the property what we have, e power minus a s into Laplace transform of f of t plus a. Here we have to take e power minus pi s. Then Laplace transform of f of t, here replace t to t plus pi. So t plus a, t plus pi. So we have to change t to t plus a. So sin t plus pi. Sin t plus pi. So we know that sin pi plus theta is minus sin theta. It will be in third quadrant. So minus sin theta. Therefore this can be written as minus sin t. Minus sin t. So then we write the final result in this way. E power minus pi s, and I'll keep minus out, and Laplace transform of sin t is 1 by s square plus 1. So this is how you can use the Heaviside shifting property. Let's see another important property, and it is very important for exam point of view. And from this what you will come to know, you can express the given function in terms of unit step function. Suppose if we have the function in this format, f1, it is a function of t, some function for the range 0 to a, and f2 for the range t greater than a, or it can be equal to a. So we have a splitted range 0 to a. Then how you can express this type of function in terms of unit step function? So we write f1 function, first function as it is, f1 of t, plus we take the difference of second minus first function. So that is f2 minus f1, f2 minus f1, and we observe what is the common value in the two intervals. A is the common value. With that we have to define the unit step function u of t minus this common value a. So this is how you can express when the given function splitted as 2. Extension is, suppose the function is splitted as 3 function with the interval 0 to a and a to b and t greater than b. In this case we write it's almost similar to the previous one, and there is an extension. First let us keep f1t as it is, then we take the difference f2 minus f1, and we observe the common value in the interval, because we are taking difference between these two. These two interval common value is what? A. With that we define the unit step function with the product, with this difference product. Next we take the difference between two functions, f3 minus f2. Then what is the common value in these two interval we have to observe, that is b. So with that value you have to define the unit step function u of t minus b. So this can be expressed in terms of unit step function. So let's see how to solve the problem, and this is a very important property, and you can expect the question, express the given function in terms of unit step function, and we have to find the Laplace transform of that. So let's get started solving problems. So we have the problem here, express the following in terms of unit step function and find its Laplace transform. First let us express the given function in terms of unit step function. So what we have, this is f1 and this is f2. Okay, we have the common value, a is pi. So first, what is the formula? F of t can be written as f1 plus f2 minus f1 into u of t minus a. This is how you can express the given splitted two function in terms of unit step function. So accordingly, we write our answer for the given function. F of t is f1 nothing but pi minus t plus f2 minus f1, that is sin t, minus f1 minus pi minus of minus plus t into u of t minus a. In our problem pi, u of t minus pi. This is how you can express the given function in terms of unit step function. Okay. Next, we find the Laplace transform of this. So just operate L on both the side. Laplace transform of f of t is equal to Laplace transform of pi minus t plus Laplace transform of sin t minus pi plus t into unit step function u of t minus pi. So we write the result. This is Laplace transform of pi minus t. Pi is a constant, so constant by s. Minus Laplace transform of t, t power n, n is 1, so 1 factorial by s power 1 plus 1 s square. Next we have in the form of Laplace transform of f of t into u of t minus pi. So this is Heaviside shifting property. So we need to shift t to t plus a, that is t plus pi from our problem. So what it becomes now according to the result. So this is e power minus as, where a is what? Where a is pi, e power minus pi s. Laplace transform of, we have to shift t to t plus pi in the f of t function. Sin t plus pi minus pi keeping as it is plus t plus pi. Now minus pi plus pi gets cancelled. We write the result. So pi by s minus 1 by s square plus e power minus pi s, and this is become, this sin pi plus t become minus sin t. For that Laplace transform is minus 1 by s square plus 1. Then what is remaining? T. For that Laplace transform is 1 by s square. So this is what express the given function in terms of unit step function and finding its Laplace transform. Okay, let's solve the another problem. Express this function in terms of unit step function first. So this is f1, this is f2 and this is f3, and this is a and this is b. So first, for the three splitted function, how to express the function? Generally it is f1, next f2 minus f1, this into unit step function with a common value of first two interval is a, is a pi. Next, I'll write a only. Next f3 minus f2 into u of t minus b in general. Okay. Now let us solve the problem. So given function f of t can be written as, what is f1 in our problem? Cos t plus f2 cos 2t minus cos t into u of t minus a, means t minus pi. Next f3, that is cos 3t minus f2 cos 2t into u of t minus 2 pi. Next we find Laplace transform on both the sides. So just we take Laplace transform on both the sides. So L of f of t is Laplace transform of cos t. Let us separate it. Next Laplace transform of cos 2t minus cos t. This multiplied with the unit step function u of t minus pi. Next we have Laplace transform of cos 3t minus cos 2t. This multiplied with unit step function u of t minus 2 pi. Then according to the formula, first term is Laplace transform of cos t. It is s by s square plus 1. Next we have, this is f of t into u of t minus a, where a is pi. So we should replace t to t plus pi, t plus a in the function. So according to the formula or property, it is e power minus as. So e power minus pi s. Laplace transform of, in the function given here, you have to change t to t plus pi. that is cos 2t plus 2 pi minus cos t plus pi. Similarly, here we have to change t to t plus 2 pi because a is 2 pi. This is a. So, plus e power minus as become e power minus 2 pi s. Laplace transform of cos 3 into t plus 2 pi. It's a cos 3t plus 6 pi minus cos 2t plus 4 pi. Okay, let us simplify and find the Laplace transform. So, the next step become s divided by s square plus 1 as it is, e power minus pi s as it is. Now, we write the result. So, what this gives? E cos 2 pi plus 2t, cos 2 pi plus 2t in first quadrant. In a first quadrant, all the terms become positive. So, we get it is cos 2t. This is cos 2t. So, Laplace transform of cos 2t is s by s square plus 4. Next, minus, so t plus pi, cos t plus pi. So, pi plus t in third quadrant. Cosine is negative. So, we get cos of t plus pi is minus cos t. Then, this along with this minus sign, this minus cos t become plus. So, therefore, it is plus cos t. Then Laplace transform of cos t is s by s square plus 1. Next we go with the third term. So we have e plus e power minus 2 pi s as it is, and Laplace transform of 6 pi plus 3t. 6 pi plus 3t become in first quadrant. We get cos 3t. So the formula of Laplace transform of cos 3t is s by s square plus 3 square is a 9. Next we have 4 pi plus t, that is also in a first quadrant. So first quadrant all the functions will give the negative positive result. So we will get cos 2t plus 4 pi is cos 2t. So that minus sign retains. So we get s divided by s square plus 2 square, it is 4. So this is the expression of the given function in terms of unit step function and finding its Laplace transform. Let's solve another example. Express the function in terms of unit step function. We have the problem 1 for the range t less than or equal to 1, t for the range 1 less than t less than 2, and t square for the range t greater than 2. First, let us express the given function in terms of unit step function. According to the formula, how we have property? Firstly, we have to write 1. Next, we have to take the difference t minus 1. The common value here 1, so u of t minus 1. Next we have t square minus t, and the common value here 2, u of t minus 2. Then we find Laplace transform of this. So Laplace transform of this f of t operating L on both the sides for every term. Laplace transform of 1, Laplace transform of t minus 1 into u of t minus 1. Then we have Laplace transform of t square minus t square minus t into u of t minus 2. So then we use the Heaviside shifting property. First term, it's a simple Laplace transform of 1 is 1 by s. Next, we have to shift here. We have a is 1. So therefore, we have to shift here t to t plus 1, and here a is 2, that's why we have to shift t to t plus 2. We have to shift t to t plus 2. So according to the Heaviside shifting property, where a is 1, so e power minus as become e power minus s. Laplace transform of shifting t to t plus 1, t plus 1 minus 1. So we are just replacing t as t plus 1 and minus 1 I written as it is. Next, e power minus as, here a is 2, e power minus 2s. Laplace transform of shifting t to t plus 2 whole square minus of t plus 2. Then it is 1 by s plus e power minus s, minus 1 plus 1 gets cancelled. We write Laplace transform of t. Next e power minus 2s, and we expand and simplify. T square plus 4t minus t become plus 3t, plus 4 minus 2 become plus 2. So then we write final result 1 by s plus e power minus s, Laplace transform of t is 1 by s square. Next e power minus 2s, Laplace transform of t square is 2 factorial by s cube. 3 into t is at 1 factorial by s square. 2 is 2 by s. This is a solution.